Hello everybody, welcome to Guidancee Education channel. We are continuing class 11 physics chapter 3 motion in a straight line, that is one dimension. In this video, we will discuss a few more basic points which we need to know to understand this chapter thoroughly well. In this video, I will clear your doubts regarding path length and displacement, speed, velocity and acceleration, concept of origin, unit of measurement, sense of time and position. These concepts will help you while drawing or plotting graphs. I will also shortly discuss uniform, non-uniform and instantaneous speed, velocity and acceleration. But before starting these topics, please watch the video completely so that you get all points clear. And if you think the video is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now. As usual, subscription is quite free. Also press the bell button and all button so that you get intimated as soon as new videos are posted. Thank you very much for your support. Okay, come let us start the class. We will see path length and displacement. I will make the points clear. A and B are 2 points separated by a straight line distance 2 meters. This is an object. It is moving along the straight line from A to B. The straight line is the actual path through which the object has moved. Change in position in straight line is called displacement. Actual distance traveled between the 2 points is path length. In this case, displacement and path length is the same. Why? Because the object is moving in straight line. In this chapter, we are considering only motion in straight line. So, in this case, path length and displacement will be the same. But in order to get the concept of path length and displacement correct, we will take one more example. Suppose the object is moving from A to B along another path, a curved path. As you can understand from the diagram, the distance along this path, that is, the actual distance traveled, will be greater than the distance along the straight line. Suppose the actual distance traveled is 5 meters. So, in the second case, the path length traveled by the object is 5 meters. That is the total distance traveled. But its displacement is only 2 meters. Although it has traveled 5 meters, its displacement is only 2 meters. The shape and length of the curved path may be anything. So, path length depends upon the path or the route that is taken by the object. Whatever may be the path length, the displacement remains same. In this case, path length is greater than displacement. Let me represent 1 or 2 different paths the object may take. In each case, the path length is different, but the displacement is the same. Path length is otherwise called distance. If the object moves from A to B and then from B to A, that is, returns to the original position, then displacement is 0. But path length depends upon the actual path or distance it is traveling. Displacement is equal to 0, but path length is not equal to 0. If it travels in the straight line, then path length is equal to 2 meter plus 2 meter equal to 4 meters. If the object moves in a straight line towards the right side, it is positive. And if it moves towards the left side, it is taken as negative. So, displacement can be positive, negative or 0. Path length cannot be negative or 0. It is always positive. That is, the total distance traveled is always positive. So, if you are asked to comment on the differences between distance and displacement or path length and displacement, the answer is the same. You have to write these points I have given here. I hope these things are clear. We will pass on to the next concept. Speed and velocity. Speed is equal to actual distance traveled. What is the actual distance traveled? It is the path length divided by time taken. Speed is a scalar quantity. It has only magnitude. It has no direction. Dimension formula is m raised to 0 L t raised to minus 1. If the object moves uniform distance in uniform intervals of time, it is uniform speed. If it covers uniform distance in unequal intervals of time, it is variable speed. Total distance traveled divided by the whole time taken is the average speed. Distance traveled at an infinitesimally small interval of time is called instantaneous speed. Small questions may be asked from this topic, therefore familiarize yourself with this, okay? Velocity is equal to displacement by time taken. It is a vector quantity, so it has both direction and magnitude. It is displacement by time taken, so displacement we have already seen is a vector quantity. So velocity also is a vector quantity. Its dimension formula is m raised to 0 L t raised to minus 1. Same as that for speed. V for velocity. If you put two lines on either side, then we mean magnitude of velocity. If we represent a line or arrow above the letter, then we mean it is a vector. If it undergoes equal displacement in equal interval of time, it is uniform velocity. Then we also say that it is uniform motion. If the magnitude or direction of velocity changes with time, then it is variable velocity and the motion is called non-uniform motion. Average velocity is total displacement divided by total time. Instantaneous velocity is velocity at an instance, that is, at an infinitesimally small interval of time. You need to remember these topics because we need it when we do position time graph or velocity time graph. Next term is acceleration. Acceleration is velocity divided by time. It also is a vector. The symbol used is A for acceleration. This is the magnitude and this means it is a vector. If you put an arrow, it is a vector. What is the dimension formula? The dimension formula is m raised to 0 L t raised to, t raised to minus 2. M raised to 0 L t raised to minus 2. Acceleration, as you can see from the formula, is rate of change of velocity. If the rate of change of velocity of a moving object is uniform in equal intervals of time, then it is uniform acceleration. On the other hand, if the rate of change of velocity is unequal in equal intervals of time, then it is non-uniform acceleration. Acceleration at an infinitesimally small interval of time is instantaneous acceleration. Velocity and acceleration can be positive or negative. If the object moves away from us, then it is positive velocity. If it is moving towards us, it is negative velocity. Acceleration is increase in velocity. If velocity decreases, it is negative acceleration. In order to plot graphs, we need to know a few more terms. Let us see that concept of origin, unit of measurements. That is, we have to measure displacement and time. So we need the units with reference to that. Then sense of time and sense of position. Let us consider this illustration. A person starts from home at 8 a.m., moves in a straight line and reaches point A at 10 a.m., continues his journey and reaches point B at 11 a.m., then again continues and reaches point C at 1:30 p.m. The concept of origin here is the time when the journey is started, that is at 8 a.m. And what is the concept of time? The time when the journey starts is taken as t is equal to 0 hour. It is marked at the origin O. In reality, time cannot be 0. But by referring to time as 0 hour, we mean it is the initial time. That is when we start our observation. At 10 a.m. he is at point A. It means he has taken 2 hours to reach that point from origin. So at point A, time is marked as 2 hours. Time taken to reach B from origin is 3 hours. So at B, T is equal to 3 hours. Time taken to reach point C is 5 hours from origin. So at C, T is equal to 5 hours. Here the unit of time is hour. It can be second, minute or day or even year as the situation demands. That is suitable to the situation. Okay? While plotting graphs, time is taken in the x-axis and position is taken in the y-axis. Unit of measurement of displacement is meter or kilometer. That is what is usually followed. The initial position, that is position at t is equal to 0 hour, is at the origin. The initial position is taken as 0, whether the object moves towards the right or towards the left. The concept of time and position is the same because these quantities cannot be negative. Negative only suggests its direction of motion. Point A is at 60 kilometers from origin, point B is at 80 kilometers, and point C is 120 kilometers from the origin. Distance between A and B is 20 kilometers and B and C is 40 kilometers. Okay. Now, how to get the concept of position? Time is represented along the x-axis. Position is marked on the y-axis, drawn to a scale. That is, so many squares correspond to a particular number of kilometers. Initial position is marked as 0 at this point. At t is equal to 2 hours, his position is 60 kilometers away from the origin. Let us mark it like this. At t is equal to 3 hours, his position is 20 kilometers further away from A. Similarly, its position at time is equal to 5 hours also can be marked. If these 3 points are connected, it will be a straight line passing through the origin. Displacement is represented by the letter x. It is represented on the y-axis. Do not confuse this with the representation of x-axis where time is represented. For displacement, the unit considered is normally meter or kilometer. So now we have plotted a graph for the motion of the person from origin O to C. I hope it is clear. I hope this video was of great use to you. If you think it is useful, do like the video, share the video with your friends who may also be benefited, and also kindly leave the feedbacks as comments in the comment box below so that I can know what you think about the video. Now, if you have not yet subscribed my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much. Take care. Bye for the present.